and dive in. Thank you everybody for joining this week's edition of Water Talks. We're going to be talking about the advantages of using your GIS data within your model. I'm going to be concentrating on InfoWater Pro this week. We can go to the next slide. Your host for today, I'm Hunter Sparks. I'm a solutions engineer at InfoWater, now a part of Autodesk, and really excited to have Kim Solberg back, a product support representative with InfoWater. She conducted one of our water talks on Fireflow, marching through that, and it was a really popular one, so we thought it was about time we brought Kim back to do another InfoWater Pro presentation, this time more on the demand allocator. And so just doing some standard housekeeping, whether this is your first or you have been to many, always just like to remind people that the goal is to create a community where you can come and ask any and all of your questions. We'll provide answers, give advice, offer insights, really trying to achieve your goal and accelerate learning. We'd like these to be as interactive as possible. So please feel free to go ahead and put your questions in the Q&A tab, as you can see here at the bottom of the screen. We like to point out the chat functionality just to let you know that we will not be monitoring that as far as questions, as well as that is not saved afterwards, so we can't go back and answer your questions. So really, if you have questions, try and put them in the Q&A. The Q&A will look similar to what it shows on the top. Always like to just say off the top that yes, this session is going to be recorded, and usually we are able to distribute it, the recording afterwards. And so just a little bit of information. Can you go back one slide?
Yes, sorry.
Yeah. No, you're fine. You're fine. They know it's live now. They know we're not just sitting back here talking over a recording. So that's always good to get out of the way in the beginning. And so some upcoming water talks, just a reminder that we are now every other week. We will still be Tuesdays at 12 Eastern. On August 9th, we're going to be talking about Info360 Insight and how we can monitor your water KPIs. And then really excited on the 23rd of August, talking about asset management, how you can prepare for some of the new developments out of California. And then just a quick overview, just so people know now that we are a part of Autodesk, how our licensing works a little bit different. We do have two different solutions still, InfoWater Pro and InfoWorks WS Pro. InfoWater Pro is an extension of ArcGIS Pro, not included. It's easy, easy Fireflow analysis, master planning, and workflows. With it being within ArcGIS Pro, you can use those features and functionalities really strong with that spatial data, and it is very dominant in North America. And then of course we have InfoWorks WS Pro still, which has a collaborative work environment, advanced hydraulic analysis engine, and really best in class for advanced utilities. And with these, they are now all subscriptions, unlimited pipes, with all of the plugins and all of the applications included for InfoWater Pro. And so with that brief introduction, Kim, I will go ahead and pass it over to you.
Awesome. Yeah, thanks, Hunter, and thanks everyone for joining. This is a water talk I'm really excited about, just because we've gotten so many requests for like trainings to go over it and in support. So I think this will be a really great topic. I'm going to quit sharing the slideshow because I prefer to show everything in InfoWater Pro, like the software itself. So before we actually get into using the demand allocator, there are a few important things I always like to cover, excuse me. The first is that the spatial projection of your data is very, very important. So everything in your model, your data frame, and the data that you plan to use in the allocation manager must be in the same spatial projection. Essentially, the reason this is that your spatial projection is what actually defines the coordinate values of everything that you can see in a model. Esri, when they do spatial joins, they are looking at those raw coordinates only, and the allocation manager uses a lot of those Esri spatial join tools. So ultimately, when we are doing the joins through the allocation manager, we are also comparing those raw coordinates. So if, say, you are using like a meter shapefile and it looks like it's on top of your model, but it has a different spatial projection, those coordinate values could actually be different. And that could cause the demand allocator to either not allocate all of the demands or not allocate any of them. So especially in support, when we see issues with the demand allocator not allocating like people expect, the first thing we always check is the coordinate systems. The next thing is just kind of like preemptively before you get into setting up the allocation manager, it's a good idea to know the demands that you expect to actually get allocated. So if you're using like meter data, then using like a quick summation calculation in Excel, for example, to have an idea of what the totals you expect will be really helpful. Once you run the allocation manager, we will get an allocation report. So it'll show you like a summary of what has been allocated, so you can compare it to that total. And then you can also go look in like the DB editor at your demands, make sure everything is associated. If all three of those match, then you are usually pretty set. Really what we're looking for is those demands to be as close together as possible between those three different places to look. And if they're very far off, then we know something went wrong and we want to go back and investigate why that is. So that's my spiel before we actually get into it. A few other things before we can actually use the allocation manager itself is that some of us may need to do some pre-processing or importing data. So to start out, any data or layer that we want to use in the allocation manager needs to be added to our table of contents. So here I have like a meter sales layer. Just to add them in, if you aren't very familiar with InfoWater Pro or ArcGIS Pro, you would go up here to this map tab and add data. And then you could go find whatever layers you plan on using and add them in. Most Esri layers will be fine to use with the allocation manager. So like Esri shape files, Esri coverages, AutoCAD files will work. There are a couple others, but those are the main examples I'd say we see. If you ever want to know if a layer would work, the easiest thing to do is just add it to your table of contents, open the allocation manager, and see if it recognizes it. And if it doesn't, then you know you probably need to use some sort of conversion tool to get that data in a format that we can accept. So there's a few other things, specifically if you are using polygons for the allocation manager. So we have three different polygon types, which I'll get into a little bit more. Typically, it's going to be a primary layer, which will have your like demand areas or service area polygons associated to junctions. And then a polygon for like land usage, if you're going to use that. And then sometimes people have kind of the amalgamation of the two of those. So like an intersection layer that carries all of that data just in one polygon. If you only have one of those, say like a land usage polygon, we would also need to create that primary layer, which again is associated to our demand or service area. So if you don't have that, you can either request it through like your GIS team or wherever you get that data from, or InfoWater Pro can actually create what's called a Thiessen polygon for you. So if you need to do that, it would be up here in the allocator toolbar, and I would just go to more and create Thiessen polygon here. I'm not going to go too much into the setup for that. I just like to point out that is an option. Essentially what it's doing is using a process called dynamic segmentation. So it's creating one polygon around each node in your model within the boundary you define. I had one created already, so I will just show it so we don't have to wait for that to be generated. So we can see of the model, and then if I zoom in, we can see there's a polygon around each junction, like I mentioned. So this would be considered like my primary layer once we get into the next steps. And a quick note on this, let me add my meters back in. So these dark blue dots are meters, if you are allocating using Thiessen polygons, all of your land use data and meters have to be inside the polygons. If they're not, then they will be excluded from allocating. So for example, I have these 4 meters right here and here that are outside the polygons. So if I was allocating using this polygon and these meters, these ones would not have meter data get associated to junctions. So that's also always very important to be aware of when you're using these types of layers. So the last step for polygons is just registering them. And this is going back to where I mentioned those 3 different layer types you can use. Essentially, you just need to tell InfoWater Pro or the demand allocator what type of layer your polygons actually are. So to do that, I will go to, again, this more dropdown up here and active layer. And it opened on my other screen. So I haven't registered any layers, so it's blank or empty. I can go to new, and then we have this window where we're just specifying, again, the layer type. So primary layer, just to reiterate, is going to be like your demand area polygons. A secondary layer will have your demand classes or classifications, so like the land usage, and then the intersected layer is if your consumption data has already been integrated with your demographic data. So for the Thiessen polygon, if I was registering this one, I would choose primary. And then since I already have it created, I can choose it from my dropdown. So if I had other polygons included, I would be able to choose them. And then since this is the primary one, I just need to specify the field within my polygon that has that connection to each junction. So it's this associated junction ID. Now, instead, if I was doing a secondary layer, for example, we can see the junction linkage field is grayed out. And because this is the one that is associated to our land uses, I would instead point to a land usage field. And then again, if I had that intersected layer, I need to fill out or select the fields for both of those. Since that's my primary, I will select that and then press OK. And so now it is registered as a polygon that I can use in the demand allocator later. So that is kind of the pre-processing or setup for our polygons. Most often we see people use meter data though. And so that if we haven't received the data in a shapefile similar to what I've shown here, we need to do something called geocoding. And essentially this is just matching a spatial location to our meter usage data. So typically we can take like an import of our GPS readings from the meters, and then we want to join it to like a billing system database, whatever we have, so that those can be tied together using like a street address. Ultimately, what we need though is an XY location, which again, that billing system database should hopefully have. So once you get those together, you can either add in a shapefile to the table of contents, like we see here, or sometimes people just have it in a CSV file or a similar file type. And there are a few options for getting that into the required format. So again, if it's like a CSV file, we can use ArcGIS Pro tools to convert it. It's in the toolbox, I believe it's called like XY to point or something like that. Or what's even easier is we have a tool in the allocator dropdown again, so that more dropdown where we could select import meter data. Essentially, all we would do there is point the tool to like our CSV file, and then we would tell it, okay, this is the field title for my X coordinates, this is my Y coordinate field, this is my demand field. And then if you have the data, you could also optionally include like usage data or linkages to specific nodes or pipes, which we'll get more into once I actually get to the allocation manager itself. So that is a lot of the setup. Just to reiterate, polygons and any layer really needs to be added to our table of contents first. Polygons then need to be registered, so InfoWater Pro knows what kind of layer it is and kind of the source data that it will have. And then meters, we just need to make sure we have that unique XY coordinate system so that we can place it in our model and as well have the demands.
And Kim, we actually have some questions which relate to this process.
Okay.
We have one. I've previously used Google Earth to geocode a list of addresses and get their XY coordinates. Is there such a functionality available within ArcGIS Pro?
Um, I don't believe so. The main geocoding service I know of that's free is done by Texas A&M. Here, I can share the link here. I have it on a slide. So if anyone wants to be able to refer to it, so it's right here, this Texas A&M geocoding. Like I said, that is a free service that's really easy to use. It's probably the easiest way to do it.
Perfect. Um, then we have another one. Would you recommend using geocode addresses to geolocate from meter addresses?
Yes, yeah. It can ultimately come down to the data you have, but I would say street addresses or like parcel addresses are going to be the easiest way to link those together, or like billing IDs, but
Perfect. Appreciate you answering this. That's all I have for right now.
cool. Okay. Yeah, so like I was saying then, once we have all of that set up, we can actually go on to using the allocation manager. So I will just open it up here in the allocator toolbar. And we'll start with this allocation tab. There is this usage data tab that you can go to after each method, but I'll go down each of the different methods first, just to keep it more simple. So the demand allocator manager, or specifically this allocation tab, is going to be the central hub for setting up your allocation methods and how everything is just going to be added to your nodes. So as we can see here on the left, we have 7 allocation methods. These top 2 are the primary ones for using polygons, like the primary and secondary intersected layers, like I was mentioning. Though these seem to be a little less common than the next ones. So then the other 5 down here at the bottom are mainly what we would use if we have that meter billing data, which I'll be showing the examples for a lot more since I have the meter data. So just starting out at the top, is polygon intersection. So this is just going to do a spatial intersection of multiple polygon layers. So if I move over to the right, we can see a lot of this bottom portion is grayed out. So as you change methods, there will be different configurations you need to set up. So we only need to carry about the active fields. But like I was saying, it's going to intersect this primary and secondary layer. And again, these are just what I would have registered in that more dropdown. So I only activated a primary layer, that decent polygon that we can see in the background. So that's why it's selected. I haven't done a secondary layer. So I wouldn't be able to allocate right now. But ideally, if you're going to use this method, obviously you would need that secondary layer. And then we just have 2 optional fields. So if your secondary layer, which again is the one that has like the land usage classifications, if it has like a build out ratio or other demographic data for like populations, you could include that as well. But again, those are optional. So at this point for the polygon intersection, once we've set those, we could then move on to the usage data tab. Again, I'll do that tab separate after going through all of these though. So next up is the polygon extraction. This is just doing a spatial summation of our consumption category polygons. So it's only looking at the intersected layer, which again is like if I had already processed the primary and secondary layer into one set of polygons. So excuse me. So again, we would just select our layer. It would show up if I had registered a polygon as the intersected layer. And then if I wanted to include build out or population data, I could do that as well. So that is pretty much it for the first 2 methods. Like I'd said, these next 5 are ones that we can use if we have meter demand data. So just real quick, kind of summarizing these a little bit, these first 3, so meter summation, closest junction, and closest pipe, which my mouse is hovering over, these 3 methods are going to identify the junctions or pipes that are closest to our meters and populate a junction field for us. Then it's going to sum all of the demands to each junction identified or associated to the meters. So essentially, we are having InfoWater Pro or the demand allocator do a spatial search to find which junctions or pipes will be allocated or pull demands from our meters. Whereas these bottom two, so meter junction and meter pipe, it isn't doing a spatial search. We are telling it which junctions or which pipes we want demands to be done to. So these two bottom methods are only going to be summing up demands. But to get into these a little bit more, so I have meter summation selected already. This is one of the customer billing data methods, or the only one, I should say, that will also use a polygon. So we have a primary layer here again. So that's these polygons. And then we have this meter configuration portion activated now. So kind of towards the bottom of it, we would want to start by specifying what our meter layer is. So I can highlight over it and we can see that it ends in meter sales. So I know it's looking at my meter layer. It's always important to check and make sure you're using the right field because it does give you the option to look for like your different element types. So we want to do meters. Then we would specify up here our demand field. So just which field in the meters has demands, and that junction ID field. So again, this is the field where it will populate the junction that is closest to the meter, and that's how it will allocate demands. Now, if you have this field, you can select it, or if we go over to the right, you can press new field, and that will allow you to create a field so it's being populated properly. And if you're kind of doing some QA, QC, you have the option to purge IDs, and this will just delete everything currently in the selected junction ID field. So just to make sure everything's being populated with the latest junctions, you can purge them. The way meter summation is going to work as well, let me close out of here, is it is going to look at the meters within each Thiessen polygon we have created, and that's how they are going to be associated to the junction. So these 3 meters in this polygon, I would expect to go to this junction. This is why, when I mentioned earlier with Thiessen polygons, having your meters within your boundary of the polygons is really important, because these 4, like I mentioned, do not fall within any of the polygons, so they won't be associated to anything. So I will open this back up. One last thing on meter summation, I do not have a domain created, but if you wanted to limit the demand allocation to specific junctions, what you can do is just manually add them into your domain, and then this apply to junctions in domain option towards the bottom would be available as well. But it's grayed out because, again, I don't have a domain right now. This next method is very similar setup to meter summation, except it isn't going to use a polygon to kind of capture the meters that will be connected to a junction. So what closest junction is doing is just doing a quick spatial search to find which junctions are closest to meters. And again, it will just be populating this junction ID field that we set with those IDs. So again, for the setup, it's very simple. We would specify our meter layer, point to our demand field, so down here, and then junction ID field, which I have as associated junction. If any of your meter layers has usage data, you can also map it right here in this usage type field. The meter that I'm using for this example doesn't have it, so that's why I'm not mapping it. So that one is totally optional. At a minimum, for meter summation and closest junction, you just need that meter layer, a demand field, and a junction ID field, so it can write down those associations it's creating. Closest pipe is the next method. This one is also very similar to closest junction. So it's operating in the same way. It's doing a spatial search, seeing which meters are closest to pipes. And then according to some settings further down, it will kind of split up or allocate those demands to either the upstream or downstream junction on the pipe it found. So first, it's going to locate the closest pipe, like I mentioned. That's going to be based off of this searching distance we specify as well. So it usually defaults to 200. This value is going to depend on your spatial projection. So it could be like feet or whatever your inputs are. Like I was mentioning then, meter demands will be assigned to either the upstream or downstream node for each of the selected pipes, and those demands can either be assigned in full or split up according to this meter assignment option down here. So going over these real quick, evenly divided is going to take the summation of all demands, so all of the meters that fall within that search range for the pipe, it's going to sum them up, it's going to divide them in two, and then assign those equally to both the upstream and downstream junctions on that pipe. Distance weighted is a little more calculation heavy. It's essentially going to see how far along the pipe a meter is, and then it'll get that weighting factor and assign the weighting to the demands being applied on both sides. So for example, say a meter has 10 gallons per minute and it's 3/4 of the way down a pipe. So it's going to take that 1/4 of the 10 gallons per minute, so 2.5 gallons per minute, and that'll go to one junction, and then the 3/4, so 7.5 gallons per minute, will go to the other junction. And then these last two are similar, just kind of reversed. So closest junction will just find whichever end point of the pipe the meter is closest to, and that's where the demand will go to. For this junction is the reverse. So whichever junction the meter is closest to, the demands will actually go to the opposite end of the pipe. You do also have the option to include laterals in your demand allocation. So we have this right here, assign pipe based on lateral line. You can select that if you would like to include your laterals, and then all you would need to do is find your lateral layer. I don't have one that's looking at my pipe layer. And then, like I mentioned before, these last two are going to be very similar to closest junction and closest pipe. I kind of consider these ones to be more of a follow-up to using closest junction and closest pipe. So the setup is going to be the same as their corresponding method. So meter junction has the same setup as closest junction. Again, we just define our meter layer, the demand field, and the junction ID field. Like I mentioned before, though, now with meter junction, InfoWater Pro isn't doing a spatial search for us to find that junction. This junction ID field is now telling InfoWater Pro what meters and junctions are associated. So really common application of the meter junction or meter pipe tools are if you ran closest junction or closest pipe, did some QA/QC, and decided to move some meters to different junctions. We would be changing this junction ID field, but the demand actually hasn't been reallocated. And I'll show this in a little bit. But what we would do is after making those changes, we would come back into the demand allocator and run meter junction or meter pipe. And now it would be using that updated junction ID field. So the demand would get reallocated to the new junction that we changed it to. And like I was mentioning, meter pipe is also the same. This one just corresponds to closest pipe. So again, we specify our meter layer, the demand field, and the pipe ID field, and then we can also choose the meter assignment option that we want to use. Since we are telling it exactly which pipe ID it's being associated to, we no longer have the searching distance option available. And then the last portion of this window is the scaling factor down here. So this is just really useful if you want to like normalize your demand data, or if you have some unit conversions you need to do. So this can be pretty applicable if you are using like polygon intersection or extraction, because this can relate to like water duty factors and some conversions you may need to do for that. So that is the allocation tab. Now, if we have used any of these methods and pointed to a usage type field, we would move over to the usage data tab here.
And
So this
Kim,
is,
before we move over to the usage
yeah,
data, we do have a question. For closest pipe assigning, do you recommend using the split demands between junctions on the pipe or just assigning it to the closest node, or does it make little difference?
I would say that's going to be very dependent on your meters and your data. Uh, and it probably plays more into like wearing different engineering hats. If anyone has been to other water talks, I know we say that a lot. So it is kind of up to your discretion as the engineer assigning this. But ultimately, I would say it just comes down to how much you care about how much they are allocated. So like distance weighted mathematically is going to be more accurate. Um, but closest junction, depending on your model again, would probably be just fine too.
Perfect. And it looks like this is why I love having these water talks, because sometimes people know things that we don't. It looks like, responding to the previous one about using Google Earth, it looks like there is a tool to convert Google Earth to shapefile/GDB. So that's good to know.
Oh, cool. That is
Always fun
definitely
when,
good to know.
yeah, it's fun when us on this side can learn something as well. So
Oh yeah,
um,
there's always those little buttons.
100%. Perfect. Appreciate it, Kim.
Yep, thanks, Hunter. Okay, so like I was saying, the usage data now is where we can um, classify or list the different land uses or whatever classification you're using. So if you have a layer selected, like or a method selected, like polygon intersection, or your metadata does have a usage type field, the easiest way to load them in is to press this red checkbox. So check usage type. It'll automatically load those in. Since I don't have it, we also have the option to just append rows. So right up here, I'll create one. And ultimately what this would end up looking like is, say for residential, my flag for that in the GIS could be R, and then I could type in the description residential so I know what it is. Most of this would automatically be populated for us. Oops, I want that. Okay. Yeah, so like I was saying, most of this would already be populated, like the water duty that we see here. So this water duty field actually relates to the water duty calculator. So this is where we can modify or create water duty factors to match some of our known production values. So typically for meters, this value is just going to be 1 because our meter and billing data should already have all the water duty calculations factored in to the data. So this will come more into play if you're using polygons. And then demand field is where we can actually apply specific usage type demands to our demand fields. So we have 10 demand fields you can apply them to. You can select any one that you would like to use. So I'll just leave this as demand 1. So now anytime I allocate a demand that has the residential water usage, those demands would all be summed up and added to the demand 1 field. Then I could add more if I wanted, or if they'd been loaded in for like commercial, and I could do that to demand 2, 3, and so on. The only caveat to this, as I mentioned, is that there are only 10 demand fields. So if you have more than 10 usage types, you will need to kind of do some extra summing up or have duplicates, different usage types going to the same demand field. And one quick note before I keep going on appending rows. So as I mentioned, you can manually add in these usage types. The big caveat to that, if you are entering values manually, is that whatever your usage type is here, it must correlate with known values in your GIS. So since I don't have any usage data mapped in the allocation tab, it would just ignore this manual residential usage type I created. So just something good to be aware of. If you make a typo, that's a really easy way that it could not be allocated properly or to the right demand field. Now, one really neat little feature in this usage data window is the option to switch from demand field here to demand pattern. I haven't seen people use this too often. but I think it's a pretty cool feature available just because usually if we are bringing in usage types and separating our demands, it's because we want to be able to apply patterns to them. So if you already have your demand patterns created, you can do the exact same thing as we did with this demand field. But now instead of associating demands to a demand field according to usage, we can associate a pattern to our demand fields according to the usage. So you would just be able to select whichever pattern you already have created, like the standard one. For example, this is a training model, so that's why we have some of these here. So really neat just to be able to use, because if you do have those patterns, it can save you a lot of time going back later and associating all of those patterns manually. And now the last thing we have to do before allocating demands is select this options button. And this is going to open the same window regardless of which tab you're in. But options, we have a few things we can, or a few options up here at the top. So the first two are normally checked for all methods, regardless of which one you're using. This is just for overriding like the associated junction IDs in the tables and overriding existing demands when you do a new allocation. And then these bottom two are only used if you're using the polygon methods. The big thing I like to point out in the options here, though, is this target demand set is going to specify what tables or like where your demands are being associated. So if you have multiple scenarios, you are probably or hopefully familiar with data sets that allow you to change data for the same elements within your model. So typically we recommend allocating to the active demand set, but again, this just kind of comes down to preference. If you have a different demand set you would like to import your demands to, you can select it here. And if you want to create one, you can just quickly press this icon right here and create a new demand set and have it selected. Similar to being able to like purge IDs for which fields pipes are being associated to for meters, you can also purge all demands in whatever demand set is selected here. So if you just want to delete everything in the table, purge all demands will do that very, very quick for you. And this is just a really easy way to make sure you don't get duplicate demands associated. So going back to that example I gave earlier, where you could change how meters are associated to junctions, if you reran it and didn't purge all demands, you could still have the same demand applied to two different junctions because it wasn't removed when you reallocated. So just something to be aware of because that can also kind of throw off the totals that people see. So once we have all of that set up, we can actually run the demand allocator. So I always like to just show closest junction. I'm not going to run it right now because I already did that. I won't make you guys sit and wait for it to calculate. But what would happen is once I press allocate demand, it would switch me over to this usage data tab, and then it would be opening the water duty calculator, which is right here. So if I really wanted to open the like output report that this creates, or if I accidentally closed it and wanted to reopen it, I would again just go to this usage data tab and this icon that my mouse is zeroing on right next to the red check mark. So as I mentioned, we can see like this usage type for residential. It's blank because again, I didn't have any fields connecting demands to a usage type. So that's why the demand here is 0. Since I didn't have that usage, it's just going to be defaulting to whatever the defaults were. So a default usage type, AKA none. Again, we can see this water duty factor, which this is really, really useful if you are using polygons. This field right here will actually allow you to modify the water duty factors being applied to your demands kind of like on the fly. And then you can see how your demands fluctuate according to those values. So for example, just to make it really easy to see, hopefully this isn't too small, I have 1471.8 demands that are being allocated. So if I increase this water duty to like 5, and just click anywhere else, we can see it automatically calculated that. So now it's in 7,000. So I will switch this back to 1. So again, just really, really useful if you are using the polygon methods to just kind of change the water duty factors being used. So this is just giving us a summary of the demands applied to each usage type. And then we have this total demand field here. And this is the one I was mentioning in the beginning that we want to compare to like our spreadsheets. This is really the first QA QC check we can do to make sure that the demands that we expect to be allocated are actually being allocated to our system. And again, if you need to use that scaling factor, you can do that as well again. So like unit conversions, anything like that. So at this point, our demands are allocated. Like I mentioned too, with the DB editor, we could open this table and go look. I can see these got allocated to the demand 2 field. They are populated here. I could then do field calculations there if I wanted to, again, for another QA QC check. But the last thing I like to cover for demand allocation is meter assignments. So like I mentioned earlier, you can actually change which meters are associated to which junctions or vice versa. So to do this, first we'd want to make sure our meter layer is selected in the table of contents. Otherwise the tool just gets finicky. It'll give you a pop-up saying it doesn't recognize what layer you're using. And if that happens, all you need to do is go highlight it in your table of contents. So it's like your active layer. Then I can go up here to assign meters, and meter layer is referencing the layer that I have selected here. And then junction meter association and the pipe meter association are doing the exact same thing. Just which section you use will depend on if you use like closest junction or closest pipe. So if you were associating junctions, then use junction meter association. If you use the pipe one, then obviously use the pipe one down here. So all we need to do in here is specify which field had the like associated junctions populated. So this is my HX_JNT. And then what I can do is I can either choose to select meters and I can see which meters are associated to which junctions. So let me do that right now. I'll highlight a bunch here. So they're highlighted in blue. I could keep on selecting, that's why they're in blue, but once I'm done, I'll just press enter. And we can see now it's drawing all these red lines. So that is showing me where all of my meters were being associated to. In reverse, I can select just one junction and it'll show me what meters are going to that one. And now, like I mentioned, if we wanted to actually change the association of meters to junctions, we can use this assign junction or assign pipe option. So I'll do assign junction. While we do this, we want to really pay attention to the message board because this is giving us the instructions for what we need to do. So this is telling me to select the junction I want to reallocate demands for. So say this, I'll do this junction. So I selected it and now it wants me to select the meters that I want to change to be allocated to it. So for example, say, this isn't a great example, but just to make it easier to show, maybe I want these 4 meters right here to actually go to the junction here that I selected. I'll highlight them and press enter. And now we can see those are redrawn. So now again, if I go back to select junction, I have these 4 meters that I changed and the 4 that were within that basin polygon for this junction. And so like I was mentioning, if I close out, you're going to get this pop-up. It's just asking if you want to reset the map display. So it will remove the red lines if you press yes. So like I was saying before now, since I changed which meters are going to be connected to which junction, I would now need to reallocate my demands. So I'd go back to the allocation manager, and this is where I would use that meter junction because I've now updated this junction ID field. So I would just reallocate, and then the demands from these 4 would go to this junction. And that is about it for what I have on demand allocator. There are just a few quick things I always like to cover. So if you ever have any questions about the demand allocator outside of like this water talk, you can always contact the technical support line. So the number is 626-568-6869. Or you can email support@innovise.com with your questions. We also have a really expansive online help file that covers all of the topics I've gone over here. So in InfoWater Pro, if you ever are in a pop-up, you can press F1 on your keyboard and it'll automatically launch the help file, or you can just Google InfoWater Pro help. And I'll just pull this over since I have it open. You can always use this search tool to look up specific windows. So you can search demand allocator and then it'll take you to this page. So really, really useful if you ever forget like what a specific field is doing. And then the last thing is we also have a quick start tutorial. So if you have paid for InfoWater Pro and installed the program, you have example files installed on your computer in this file path that it mentions. And there are actual step-by-step instructions that will allow you to use each of those different methods in the demand allocator. So really, really helpful to go and review if you ever need it. But otherwise, Hunter, you can let me know if there are any other questions.
Yeah, and before I bring in any of the other questions, I just kind of want to echo what you said as far as our support team. As someone that was learning to get up to speed on this program without prior experience, you guys have been extremely beneficial. And then at the same time, the help resource for InfoWater Pro, there's so much information in there. And I think what you mentioned about those quick start tutorial about every single application within InfoWater Pro allows you to give you a set of information that you can do a tutorial on without actually having to mess with your own system as you're trying to learn a tool. So I found the online resources to be extremely helpful for InfoWater Pro.
Definitely. Yeah, just about anything you need, you can find in there.
And we do have a couple questions. One of them, will this change the junction field in the meter layer? Might need to get a little bit more
Uh,
information, Kim, unless you know right off the top of your head what this is referring to.
I'm guessing they mean the meter assignment window I just showed. And
Mhm.
yes, so if you change the junction, like I showed at the end, it will change that junction layer in your meter file.
Perfect. Yes, and we got confirmation that is what they were talking about. So perfect. Is there a way to exclude transmission only pipes from the closest pipe allocation process? Would you use the domain of the whole system and then remove those pipes from the domain?
Yes, yep, that's exactly how I do it. You can just use the domain to select the pipes that you only want to include.
Perfect. And then we have one. Has your GIS connection connected with AutoCAD Map 3D or only module linked to Esri products?
Ooh, that's a good question. I am not too sure of the answer to that. I know, like I mentioned before, there are a few like CAD files you can bring in, but that specific question is something that I would need to look into a bit more just to confirm and get back on to them with.
Perfect. That's the good part about having all these questions followed up with us afterwards. Just a few others. Are specific methods recommended over others?
Yeah, I would say this is a multi-part answer. So in a perfect world, if we had like the perfect model, all of our laterals and hydrants are imported, we have a lot of junctions, it really technically wouldn't matter which one you're using. Obviously, we don't live in a perfect world, so then it can start to matter a little bit more, ultimately because we may not be trying to make our models perfect. We want them to be hydraulically functional and realistic to our system without having to do all the extra work that may not be necessary to get there. So then I would say, again, ultimately it comes down to your data type. So I mean, if you only have polygons, then you can use the polygon layers. I personally prefer the meter allocation methods. And I would say there's a trade-off specifically between closest pipe and closest junction. Just because closest pipe is going to be more mathematically heavier, it does give you a little bit more accuracy for allocating, but it's also going to be slower because there are those additional calculations that it has to do. If you don't want to deal with that trade-off, I'd say closest junction is the one I prefer. Kind of gives you more bang for your buck, I'd say, because it should still ideally be accurate, but it'll also be quicker than closest pipe. The one caveat to closest junction I would mention is that it won't give you as much control over allocating demands across pressure zones. So that is one thing that is important to be aware of. So we should know where our pressure zones are, so we can always use that meter assignment option to just make sure that isn't happening, because we want demands within a pressure zone to remain in that pressure zone ultimately. So overall, I personally prefer closest junction, but again, it kind of comes down to your data and that engineering judgment of what trade-offs you're willing to take or accept.
No, that's great. That's a really great answer for that one. A lot of good detail. And you touched on some of the pros and cons to each, especially when it comes to run times and how long it can take, how you can speed it off and speed it up and have some of those trade-offs. But are there other specific pros and cons to these methods that are good to know about, or is there a place to kind of dive a little deeper into them?
I would say what I listed would be the main pros and cons. Yeah, and it kind of just circles back to the data you have again. So if you have like your junction or pipe IDs already in your layer for how they should be associated to meters, then the meter pipe or meter junctions are going to be applicable to you. Now, if you don't have it, you don't want to use them, and that's where maybe it would be more advantageous to use meter summation, closest junction, closest pipe. But for individually each one, I'd say what I was primarily saying about closest pipe and closest junction would be the main pros and cons.
Perfect. That is all the questions that I am seeing coming through to us. Um, Ended a little bit early. We can stay on here for another minute just to see if any other questions come through. As you can see on the screen, these are our email addresses. If you have some other questions you would like to address offline or after this presentation, please do not hesitate to reach out. But if there are no other questions, we can go ahead and see, always like to say that before just entering, because we have another one that just came in.
Oh, perfect.
Would the best way to assign demand within pressure zones be closest pipe / junction and then manually check with assign meters?
Yeah.
Perfect.
I will say also the question about a GIS connection with AutoCAD Map 3D. I had another support member who knew the answer message me. So I can just read that right now if the person who asked it is still here. He said, if you have anything you could add as a GIS database, generally you could link to it as a database linkage, but natively most things are geared toward the SRE architecture. But if it is any type of database, generally, or anything you could add as a layer in ArcMap or ArcGIS Pro, you most often or like generally can import it or find a way to do so. So yes, it sounds like there may be a little bit extra work to that though.
Perfect. Always good when we don't know the answer, either the audience or some of our experts in house can help us in that direction. And then just a reminder that the recording will be available online or on demand. And so I think that is the end. Thank you everyone for your time. Kim, thank you so much for joining us again. I know you and I have talked offline how after the Fireflow tool, I think our minds both came to Demand Allocator because it's one that we constantly get questions on, whether it's in demos or support. It just seems to be a tool that a lot of people use and a lot of people need would benefit from a walkthrough. So just really appreciate your willingness to hop on and do this with us again. And thank you.
Yeah, for sure. Thanks, Hunter. And thanks everyone for joining.
Take care, everybody.